Alright, today we're going to finish out the second part of actually 8C. So if on your notes you happen to have 8B, just cross that off because it's going to be 8C. And what we're going to focus on is predicting products. Okay, we spent the first part of 8C talking about different types of reactions, our different classifications, and now we're going to focus on predicting the products for those. And two slides are out of order, so you kind of need to actually go backwards one here. But remember, synthesis was where we had two singular things, so two elements, and we created one compound. And when we predict the products, we're going to mostly, for synthesis reactions, focus on ionic products, which we've been doing all along, because all you really have to do is cancel the charges. Covalent products are really beyond the scope of this class, so we're going to mostly focus on ionic. So if you look here, this would be an example of where we combined aluminum solid and chlorine gas. Now the formula we're going to get is aluminum chloride, but you also, in order to get that, you just go to the ion charges. Okay, so you'd have aluminum chloride, or aluminum rather, which is a 3+ charge. Now when chlorine, even though it's diatomic, it still forms two chloride ions. So you still will get two chloride ions out of this situation. So when we balance it, we've got to balance the aluminum 3+, the chloride 1-. You crisscross them, you get AlCl3. Now, in terms of making a stab at the products, states, just do your best on this one. I'm going to give you these in the problem. Take a stab, as long as it's not unrealistic. You know, you're not going to take a solid gas and get a liquid. But then we do need to get it balanced. And in order to get it balanced, if we started with the chlorines, if we put a 2 here to get 6 chlorines and 6 chlorines, we then have to put a 2 in front of the aluminum out here. All right, now the next example we're going to have for some more synthesis is barium metal. So barium solid. We're going to react that with sulfur. Now remember, sulfur is one of those exceptions that we find is S8. Okay, you've got your diatomics, but you also have phosphorus, which is P4, sulfur, which is S8. Now when we go to write this compound, you're going to have barium, which is a 2+, because when we write the formula, you got to think about the ion charges. You're going to have sulfide. These, if we crisscross, you get Ba2S2. Those cancel out to give you BaS. Now to balance it, this is what we got to do. We got to take into account that 8. So I've put an 8 here in front of BaS. It's going to give me an 8 here in front of barium. Okay? All right, then we're going to have magnesium metal, which is a solid. We're going to react it with bromine. Now if you look at the periodic table, bromine is one of the only elements that's a liquid at room temperature. But bromine is also part of Hunkel fiber, so it's Br2. Now when we predict the products, we got to think about the ion charges. And if you're awesome at ion charges, don't worry about writing it. Everyone else, which is most of us, take the time to write them out. Magnesium's a group 2, so it's always going to be 2+. Again, bromine, when it splits up, is a halogen, so you're going to end up with a couple of bromide ions. So when you react it with bromide, you're going to get Mg Br2, and it's already balanced. You've got 2 bromines, you've got 1 magnesium, and we're good to go. Okay, then we're going to have decomp. Now remember, decomp is going to be the opposite of synthesis. You're going to take something whole, you're going to split it into 2 parts. So if it's binary, you simply break it into the elements, and that's, again, there's more than these, but that's what we're going to focus on for the scope of this class. And if we can get good at that, then we'll be okay. So if you have potassium bromide, if you're going to split it up, the only thing you can do is split it into its elements, and you just need to remember that bromine is part of Hunkel fiber. Okay, so you got to write it as Br2, and then in order to get it balanced, you would just need a 2 in front of the potassium in order to get that balanced. Okay, so that's it. I mean, you just got to decomp, you just opposite. You take it, you split it apart. Now, I've got some other examples here. Oops. Okay, liquid water, we're going to split it into hydrogen, which is a gas at room temperature, oxygen, which is a gas at room temperature. I just got to get it balanced. I need a 2 here to balance the oxygens, a 2 here for the hydrogens. Lithium, I've got lithium, which is a solid, and then I have nitrogen, which is part of Hunkelfibber, which is going to be a gas. To get a better feel on these, remember the big periodic table in the room is color-coded based on states, so that may be a little bit more helpful. Okay, I'm going to balance the nitrogen first. I'm going to show you why. I'm going to put a 2 here in front of the entire compound to balance the nitrogen. Then I can balance the lithium because 2 times 3 is going to be 6. Okay. Then lastly, I've got solid aluminum sulfide. That's going to separate into aluminum solid and sulfur solid, which if you remember is going to be S8. So if I get these suckers balanced, there's no common denominator between 3 and 8, so I'm going to go ahead and put an 8 right here, which is going to mean I'm going to need a 3 right here. So now my sulfur is balanced. I've got 24 of them, but it's balanced. And then aluminum, 8 times 2 is going to be 16. So that's what's going to go in front of that element. Okay. All right, now single replacement. There's 3 types of single replacement. Remember, you've got a metal replacing metal. Actually, this should say or hydrogen. You've got a nonmetal replacing a nonmetal, and that's it. So what you have to figure out is here is my element. This is a metal. So what it's going to kick out is the other metal. So I always write that first. Okay, I always go, okay, I'm going to kick out the copper solid, so that's going to be the first part. Then what I have to do is pair up, make a new ionic compound between iron and what's left. And I know that since this was a 1-to-1, or that this had to be sulfate, which is a 2-, I'm going to go ahead and I made iron 2. I would have also accepted if you made iron 3, but I went ahead and made iron 2, one because it's easier to balance, but that's where I get my new compound. So let's do a couple more samples of those. So if I have zinc and hydrochloric acid, the zinc is a metal, and remember, if a metal is going to kick something out, it can only kick out another metal, okay, no other metal, or hydrogen. So my first product, if zinc kicks out hydrogen, is going to be H2, which is a gas. All right, and then the zinc is going to pair up with the chlorine. So to write that formula, I'm going to have zinc, which is a 2+, chloride, which is a 1-. So my formula for zinc chloride is going to be ZnCl2. Okay, and this is going to be one of those aqueous. We'll come back to this later. But to get everything balanced, I just need a 2 in front of the hydrochloric acid. Okay, and then I've got my reaction. All right, magnesium and lead-2 nitrate. Again, the metal is going to kick out the other metal, so the first product is going to be lead solid. And I think at the end of this unit, when we actually see these reactions, hopefully it's going to make a lot more sense. But now what I got to do is pair up magnesium and nitrate. And magnesium is a 2+, nitrate is a 1-, so my formula is going to be MgNO3, 2. Just like it was over there. Okay, and everything's balanced. I've got 2 nitrates, 1 magnesium, 1 lead, so I don't need any coefficients out front. Now this time I've got a different one. Chlorine is a halogen or a nonmetal, and so that chlorine is going to kick out the other nonmetal. So what I'm going to get here, I'm not kicking out potassium this time, I'm kicking out bromine, which again is a liquid at room temperature. Then I'm going to have the potassium and the chloride pair up, and potassium is a 1+, chloride's a 1-, so my formula is going to be KCl, and to get it to balance I am going to need a 2 in front of the potassium bromide and a 2 in front of the potassium chloride. Okay, double replacement. We're going to switch the negative ions here, and so remember, double replacement is where you're going to have 2 compounds. A plus B plus CD is going to give us AD plus BC. So we end up just switching, whatever you want to think of it, but the way this is written is switching A and C. So if I have lead nitrate and potassium iodide, I'm flip-flopping the ions. So I would then pair up the lead and the iodide and get lead-2 iodide, or PbI2, because lead is a 2+, iodide's a 1-, and then I'd get potassium nitrate because I'm pairing up my other 2 that are left, and they're both a 1-to-1. To get it balanced, I would need a 2 in front of both the potassium iodide and the potassium nitrate. And remember, we will do lots and lots and lots of practice in class. Okay? All right, let's do a couple of other samples. Up here you have potassium or barium chloride and sodium sulfate already written for you. Just another sample. Remember, we're going to now switch it. We're going to flip-flop the barium, pair up the barium and the sulfate, and you always, always, always have to have a new combination of positives and negatives. You're not, the biggest mistake people make on these is they try to pair up barium and sodium, and if you take the time to write those formulas, hopefully you're going to recognize, okay, I can't pair those up. They're both too positive, so I've got to be a positive and a negative. So this one is double replacement. Now if we come down here, so if I flip-flop iron 2, this would say iron 2 sulfide, although I would know that from the formula of sulfide, but that's okay. So if I combine iron 2 and chlorine, iron 2 is a 2 plus, chloride is a 1 minus, so it's going to be FeCl2, which is aqueous. Don't worry about the states on this side. As long as you take a stab, I'm more worried about can you predict the chemistry. Then I have hydrogen and sulfur to pair up. Remember, hydrogen is always a 1 plus, sulfur is a 2 minus, so this new formula out here is going to be H2S. And then to get it balanced, I do need a 2 in front of the hydrochloric. All right, and then last but not least, this is actually a really common acid-base reaction. This is one of the chemical reactions that takes place when you take Tums or an antacid to try to calm your stomach down. So I'm going to combine the hydrogen and the negative hydroxide, and that's actually going to give me hydrogen is a 1 plus, hydroxide is a 1 minus. That's water in another form, so you can write it as HOH or H2O. And then I also am going to now pair up the sodium and the chloride and give me NaCl, which is aqueous in solution. And everything is all what we refer to as a one-to-one, so I don't need any coefficients, which makes life a heck of a lot easier. Okay, lastly we've got combustion. Combustion, if you're predicting products, typically there's always oxygen, because remember, for oxygen we're reacting something with oxygen. Okay, now if it's the combustion of a hydrocarbon, your products are always going to be carbon dioxide and water. Always. Okay, and if you have, so for example, now this one is not a hydrocarbon, this is a regular combustion reaction, but if I combust sodium in the presence of oxygen, I form a new ionic compound on the other side, and all I have to do is balance my charges, and since sodium is a 1 plus, oxide is a 2 minus, this is what I end up with for my formula. And to get it balanced, I do need to put a 2 to get the oxygen to balance, and then I got to put a 4 out here to get the sodium to balance. Now this is the reaction of propane, okay, and oxygen, and it's going to combust like this. Since it is a hydrocarbon, all right, it's always going to be carbon dioxide and water. So I'm going to have carbon dioxide and water automatically, and when you balance these, try to balance the carbon first. Okay, so if I balance the carbon first, and I know it all popped up at once, I've got the 3 here for carbon dioxide. Then if I go back and balance the oxygen, actually balance hydrogen second, I've got 8 hydrogens, 4 waters, all right? And you don't have to do it in this order, it's just what works for me. Now the oxygens, the reason we have 5 or 10 total over here is because I've got 3 times 2 is 6, 4 over here, so that's why I have to have 10 total oxygens. All right, a couple other examples. Oh, I just did propane and oxygen, so I won't do that one again. But sometimes if I have hydrogen and oxygen, there's a couple of different ones that we can put here. In order to make it balance correctly, I'm going to go ahead and make water. I could have also done hydrogen peroxide and make it easier, but if I've got water on this one, I'm going to put a 2 to balance the oxygen, and then I need a 2 in front of the hydrogen. And this is just an example, just like the last slide, where sometimes a reaction can be both combustion and synthesis. Okay? I know it's a lot. We will do lots of review in class, and I hope that helps.